Welcome to Summarize Science, where we break down complex research for everyone. Today we are looking at a clever solution for a common problem in wireless technology research. Scientists often need to measure how individual parts of an antenna array send and receive signals, known as the active element pattern. To get these measurements right, the antenna needs to spin on a very precise turntable. The big issue is that professional-grade turntables can cost tens of thousands of dollars. This high price tag often keeps smaller labs from doing advanced research on 5G or radar technology. Researchers at Baylor University decided to tackle this by designing their own motorized turntable using 3D printing. They had a specific set of goals, like ensuring the device could rotate 180 degrees without any friction or jitter. It also had to be strong enough to hold heavy antennas and the bulky cables that connect them. The design process wasn't easy and went through several iterations. Early versions failed because the 3D printed plastic would snap under the weight or warp from the heat of the motor. Heavy cables were also a nightmare, as they created a twisting force that would shatter fragile internal components. After several tries, the team developed a two-level system that uses roller bearings to support the weight. This took the physical load off the motor, allowing it to spin much more smoothly and accurately. Let's look at the final design, which is made of 6 main 3D printed parts. Most parts are printed in common PLA plastic, while the motor mount is made from a tougher resin. The system uses a NEMA 17-stepper motor, which is the same type of motor found in many 3D printers. This motor provides incredible precision, allowing for movements as small as 0.007 degrees. They even included a mini circular level and angle markers to make sure everything is perfectly aligned during tests. Here you can see the fully constructed device with its antennas and cables attached. To solve the cable problem, they used specialized connectors that kept the heavy wires from pulling on the sensitive electronics. By mounting the whole thing on a standard tripod, they can keep the antennas away from the floor and walls to prevent signal interference. Now, let's look at the most impressive part, the cost comparison. Commercial models from big manufacturers can cost anywhere from $9,000 to $15,000. This 3D printed version was built for a total material cost of just over $111. Despite being so cheap, it offers better rotational resolution than some of its incredibly expensive competitors. To recap, these researchers proved that smart mechanical design can replace expensive industrial hardware. They successfully mitigated cable torque and heat issues that plague DIY designs. This means that high-fidelity antenna measurements are now accessible to schools and labs with very limited budgets. In the future, they hope to improve the motor efficiency and experiment with laser-cut materials. This project highlights how accessible technology like 3D printing is democratizing scientific research. Thank you for watching Summarize Science, and stay tuned for more breakthroughs that change how we see the world.